welcome back. In my previous video I talked about the product rule and I illustrated the product rule with an example. Now guys, in this video I want to talk about the quotient rule. Again, I'm not doing a rigorous verification or rigorous proof of this quotient rule. Rather, I'm just going to write the rule and then I'm going to illustrate this by an example. Guys, I also want to remove some misconceptions that some of the students have sometimes. So I'm going to illustrate that also with an example. So first of all, guys, the quotient rule, this is how the quotient rule looks like. So if I have a quotient of, let's say, f of x over g of x, and then we want to find the derivative of that quotient. So to find the derivative of that quotient, what we have to do is we have to take the derivative of the first function times the second function. In this case, it's minus. Remember, in the product rule, and that's how I remember it. Like for the product rule, it was just a plus. In this case, it's minus, and then it's g prime times f. Guys, keep in mind, like in the product rule, when we had a product of these two functions, it was f prime times g plus g prime times f. But in this case, for the quotient rule, it is f prime times g minus g prime times f. If you're trying to remember it, if you are allowed to use a formula sheet, then that's fine. You don't have to like worry about remembering. But I mean, I think it's not too difficult to remember. Guys, there's one extra piece here, which is you have to divide by the square of the denominator. In this case, which is like g, we call it g, so it's going to be g squared. But it's not, keep in mind, it is just the denominator. We can call this f and this g or h, whatever, it does not really matter. All you have to understand, like, how does the quotient rule look like? You got to divide by the square of the denominator, and then you got to find the derivative of the numerator times the denominator minus derivative of the denominator times the numerator. That's how I like to remember it. So guys, the common mistake that students sometimes make with this is like they think of this as again, it's the same thing that I tried to explain when we were talking about the product rule. They just kind of distribute the derivative or the prime here. So they say like this could be equal to f prime times g prime. And guys, again, this is not correct. This is incorrect. Okay. So, and I'm going to illustrate that with a simple example as I did in the case of the product rule. But guys, if you really want to see the actual proof of this, please go back to your textbooks and you can check out that proof as well. I'm also going to remind you right here the power rule, because that is something we have to always keep on using, whether we use product rule, we use quotient rule, and later we're going to learn some other rules, guys. But the basic foundation or the basic rule is the power rule, and we got to keep on using it. So the power rule is n x to the power n minus 1, and that is my power rule, and it is very powerful because we have to keep on using it. So guys, let us take an example, and then from that example we can see that this is not going to be true, and then this is a valid way of actually refining the derivative of a quotient. So how about if I want to take the derivative of x to the power 7 over x to the power 2, right? So it's a quotient. It looks of the form f over g, right? So guys, first of all, let us see if we can do this, find the derivative of this quotient without any of the fancy rules, okay? So guys, keep that in mind with anything or everything in mathematics. First, try to see if there's like simple basic methods that one can use to solve or simplify or evaluate things. So don't forget the power of like the basic simple methods. They are very powerful, guys. Many times I see students like using all the complicated stuff, and then later they realize, or we realize that, hey, this could be done by a simpler basic technique. So guys, keep that in mind. First, go back to the basics. If those simple ways and techniques don't work, then we should go to more like complicated or more rules and more things, okay? In this case, if I just have to use the simple way of doing it or simple basic technique of doing it, what I would do is I would just simplify this, or I will try to transform this into x to the power n form, and we have these nice exponent rules which tell us that when we are dividing these two, it's simply just going to be the derivative of basically x to the power 7 minus 2. We just subtract the exponents, so 7 minus 2 is just going to be 5, and then this looks of the form x to the power n. We can just directly use the power rule, and the final answer is going to be just 5x to the power 4. So that was very easy, and guys, I mean, I chose an easy one because all I want to do with this example here is just to illustrate that, hey, this is not correct. Please don't use it, okay? I don't want any of my students or any of the students watching these videos to make any of those mistakes. So guys, that's why I decided to actually illustrate this with some examples. Now let us go ahead and let us confirm first of all, let us confirm if the quotient rule actually works and gives us the same exact or the correct answer. So let's go ahead and do it. So I got to do x to the power 7 over x squared, and you got to take the derivative of this. So in this case, we are going to identify this as f and the denominator as g. I'm just trying to be consistent with the definition or the formula or the law, whatever you like to call it. And guys, this is going to be f prime. So f prime is 7x to the power 6. I still have to use the power rule for each of these pieces. Then times what? Times g. I don't have to do anything with g except for I just have to write it here. Then minus, guys, g prime, the derivative of the denominator. The derivative of x squared is simply 2x, and I have to multiply this by the numerator, which is x to the power 7. Okay, we did that, and don't forget to divide everything by the square of the denominator, x squared whole square, x squared whole square. Now let us simplify. This is going to be 7x to the power, well, 6 plus 2 is going to be 8 minus 2x to the power 8, and then divided by x to the power 4, right? Just simplifying. Guys, these are like terms in the numerator. 7 minus 2 is what? 5. X to the power 8, and then in the denominator I have x to the power 4, right? So we can still simplify, and when I simplify I will get 5x to the power 8 minus 4 is just 4. So I got the same thing that I have here that confirms that this quotient rule, the right hand side, the way we write it is actually correct, right? Of course, it just is verified only for this particular example. Mathematically, we cannot just generalize this, but guys, if you really want to see the rigorous actual proof, you got to check it out from your textbooks. But for this particular example, we are convinced that this actually is the correct way of writing, or correct formula, or correct rule. Okay. Now let us also at the same time convince ourselves that this is not the right way of evaluating the derivative of the quotient. Okay. So I may have to get rid of something so that we can actually see that. So let me get rid of this, and I think I'll try to squeeze in. Probably we can do it in this space. So guys, the left hand side, I don't have to worry about the left hand side. I already have the value for the left hand side. I have 5x to the power 4. All I have to see is, let me evaluate the right hand side and see what I get. If I get the same thing, then it's true. If not, then this is not valid. So I have to do f prime. What is my f? This is my f. F prime is 7x to the power 6. Not too difficult using the power rule. And then g prime is just 2x. If I simplify this, 7/2 is, well, if I want to leave it as a fraction, I can leave it like that because I don't want to get decimals or anything. So I'll leave it like this. I can already see that it's not 5. So, I mean, it's not going to be same as this. But then let me also simplify the x piece. So it's x6 minus 1 because there's an invisible 1 there. 6 minus 1 is 5. So this is, of course, we can clearly see that this is not equal to 5x to the power 4. That means, guys, we cannot do this when we are trying to find the derivative of a quotient. So to find the derivative of a quotient, if you have simple functions like these, then you just simplify and use the power rule right away. If we get more complex functions, and we are definitely going to deal with more complex functions, then first thing, we're not going to do this. We're going to use this rule because this is a valid rule. Okay. So guys, in my next videos, I'm going to start doing a lot of examples using the product rule, the quotient rule, and of course we are still going to use the our power rule. Okay, till then, take care. I will see you next time.